Have you ever just, looked around and wondered how everything gets built? I mean, from the massive bridge you drive over every day to the simple soda can in your hand, everything has a story. So today, let's pull back the curtain and see how these things, from the totally one of a kind to the one in a million, actually get made. So let's start with this. A custom-built bridge and a million cans of soda. What could they possibly have in common? On one hand, you've got this incredible, unique feat of engineering. On the other, a product so common you probably don't even think about it. Well, the secret that connects them is manufacturing, and that's the blueprint we're going to follow today. We are about to go on a journey through what's called the scale of production. It's really the story of how we go from making just one single thing to making things in small groups, then making millions, and finally to processes that literally never ever stop. And here's our roadmap for the trip. These 4 scales of production, they're kind of the secret code to understanding how pretty much everything is made. So let's jump in with the first one. First up, making just one. This really happens in 2 main ways. You've got your prototype, which is like a first draft of a book. It's a test version you use to work out all the kinks. Then you have a one-off. Now that's the final, finished product, but it's totally unique, usually made to order for one specific customer. And the range here is just incredible, right? One-off production can be absolutely massive. We're talking a ship or a whole stadium. Or it can be incredibly personal, like a custom piece of jewelry or that perfect piece of bespoke furniture. The key thing to remember is there's only one. Okay, so let's scale up a bit. What if you need more than one, but you're not making millions? Well, that's where batch production comes into play. You make a specific number of an identical product, let's say 500 blue widgets. When that batch is done, you can start a new one. And that next batch could be a little different, maybe 500 red widgets. It gives you flexibility. What's really fascinating about this is that a local bakery making a batch of croissants and a high-tech facility building jet engines are basically using the same idea. It's all about producing in these defined, manageable groups, whether you're printing today's newspaper or putting together flat-pack furniture. And now we hit the big one, mass production. This is that classic assembly line you see in your head. The goal here is really simple. Make a ton of a standardized product as cheaply as you possibly can. Every single item is a perfect copy of the last one. So here's the crucial trade-off. You get insane speed and a super low cost for each item, but you totally lose flexibility. Changing that assembly line to make something new is a massive, expensive headache. This system is what we call capital intensive. You got to invest a ton of money in machinery to even get started, and it only pays off if you're making a whole lot of the exact same thing. Finally, we get to the absolute peak of manufacturing, continuous production. With this, the factory literally never shuts down. It's just a nonstop flow, running 24/7, processing raw materials without a single break. These are kind of like the invisible engines that power our modern world. I mean, think about it. You don't order a batch of gasoline or steel, right? These are commodities that have to be produced in a constant, unbroken stream just to supply all the other industries we've been talking about. Okay, so we've got the scale down, but how do you actually organize a factory floor to make all this work? Well, it all comes down to the blueprint you choose. And there are really 2 classic blueprints. You've got the product layout. That's your typical assembly line where the product moves from one station to the next in a straight line. It's built for speed. On the other side, you have the process layout, which groups similar machines together. So all the drills are in one area, all the lathes in another. The product travels between these zones. This one is built for flexibility. And that brings us to a more modern, leaner approach called cellular manufacturing. It's basically a hybrid. You create these little mini assembly lines called cells for specific product families. And they're often U-shaped, which is clever because it lets one worker easily manage multiple steps. This design gives you the speed of a product layout, but with the flexibility of a process layout. It's really the best of both worlds. Now let's talk about who or what is actually doing all this work. And look, this isn't some simple story of robots taking over. It's really a spectrum, from the delicate human touch all the way to full automation. Believe it or not, sometimes a human is still the absolute best tool for the job. For tasks that need incredible dexterity and problem solving, like, say, carefully fitting the airbags into a car's dashboard, a person's adaptability is just something machines can't match yet. Then at the other end of the spectrum, you've got full automation. This is where robots and conveyor systems do all the repetitive, heavy lifting, all programmed and watched over by their human coworkers. This is how you get incredible consistency, precision, and of course, just massive production volume. And not all robots are created equal. A Cartesian robot moves in simple straight lines, perfect for things like 3D printing. An articulated robot looks and moves like a human arm, doing everything from welding to packing boxes. Delta robots are these super fast spider-like machines for delicate jobs, and then you have cobots, which are designed to work safely right next to people. So what's the brain behind all this robotic muscle? Well, it's something called computer-aided manufacturing, or CAM for short. This is the software that takes a digital design and translates it into a set of instructions, or toolpaths, that tells the machines exactly what to cut, where to move, and how to do it step by step. So when you boil it all down, the story of how everything gets made is really a story of trade-offs. It's the custom detail of a one-off product versus the incredible efficiency of mass production. It's this constant balancing act between uniqueness and volume, and that balance has shaped the entire world we live in. And all this leaves us with a really fascinating question for the future. We've seen this huge gap between a unique one-off item and a mass-produced one. But as our robots get more precise and the software gets smarter, will those lines start to blur? Could we actually reach a point where the awesome efficiency of mass production can deliver a product that is perfectly, uniquely customized just for you? Something to think about.